So welcome to this session about micro-frontends and serverless. Let me start with a quick survey. So how many of you have a distributed system in production today? Okay, fantastic. So how many of you, keep your hand up, please? Perfect. How many of you have a micro-frontend implementation today in production? Okay, kind of. Okay, not many. Perfect. So if you don't have it, if you don't have one, you might be needed because if you're using distributed system and you are leveraging those capabilities, that is independence of teams and the possibility of deploying independently and reduce the risk of a new deployment, micro-frontends could help you on that. So who am I? My name is Luca. I'm a serverless specialist based in London. I work for AWS. I'm an international speaker and the book's author. So I'm writing right now my third book. So quite a lot of fun. Let's start first with describing what micro-frontends are. I think is quite important that we are on the same page for progressing the discussion today. So when I started back in 2015, there wasn't a definition, so I had to figure it out by my own. And not even the term micro-frontend was there. I think it was coined by ThoughtWorks in 2016. So the definition in this case is that micro-frontends are a technical representation of a business subdomain. If you're familiar with domain-driven design, probably you know what I'm talking about. They allow independent implementation with same or different technology. They should minimize the code share, and they're owned by a single team. So as you can see from this definition, there are a lot of things that are highlighted. So let's try to drill down in each single of them. So there are technical representation of a business subdomain. What does it mean? So first of all, one of the things that I have seen very often when new teams or companies are embracing micro-frontends are trying to map micro-frontends with the components. The reality is they are not. And the main difference behind that is that the component tends to leak its domain outside the container. So the container knows how to interact with the component and how it should behave based in a specific context. Instead, micro-frontend should be self-aware. And therefore, when you are designing micro-frontend, in order to be self-aware, you need to have already a lot of the context. That usually you have like a bunch of information that you retrieve from local storage, cookie, or query string, stuff like that. But vast majority of the time, if you find yourself that you have a lot of, let's say, part of your UI that they are leaking their domain into the container, probably you need to review your boundaries. The second part is independent implementation. Why we need to have the boundaries well set for a micro-frontend? Because otherwise you won't have independent implementation. The problem that we are trying to solve here is that we want to have like microservices specific API that we can communicate with between micro-frontends, but at the same time we want to have independent teams, and that leads to have also independent deployment, and that will allow you to do a lot of things that we are going to see also today. Another characteristic is that micro-frontends might use different technologies, but I don't encourage you to optimize for that. I know that there are several blog posts and let's say people on social that are thinking, oh, okay, I would use micro-frontends mainly because I can use Angular, Vue, and React all together. The reality is we are making our front end inefficient. And to be honest with you, in a single page application, you can do the same. I remember back in the days when React came out, that was only focused on the UI part and introduced the virtual DOM and so on and so forth, that the Angular community started to look into React and say, oh, maybe we can use React with Angular. And then suddenly they understood, okay, probably it's not the best idea. So Angular started to work to have, let's say, a better rendering engine for their DOM. And then that definitely they take different path. And then it's very important to understand that you might have certain situation where you can have multiple technologies. For instance, if you are migrating from an existing framework to same framework but different version, or to a brand new framework, yes, there are a certain period of time where you will ask to your customers to download more code. But that doesn't mean that it should be a playground for developers and forgetting about the final result that is our customers. The other controversial part of this definition is code sharing. And I know that many times people are thinking, oh, okay, so I create micro-frontend, so I can encapsulate my logic and can reuse everywhere in my application. That's not exactly what we're looking for. Yes, there are some parts that should be shared, design system, logging, library, for instance, stuff like that. But that doesn't mean the moment that you see two lines of code that are identical, let's abstract and let's reuse everywhere. Because you need to make aware all the other part of the organization that there is now a new library that could be used or should be used, and then force that part, and then you need to maintain that. Writing code is easy. Maintain code, slightly less so. Last but not least, I think in 2023, it's time that we take ownership of our code end-to-end. That doesn't mean we write some code and we throw on the other side of the fence, someone else will take care of deploying production. We should own it till the production phase, and also when the code is in production, having our dashboards and our observability tools that will tell us what is broken, because imagine that you have multiple micro-frontends in the same view, and then suddenly one part is broken. That means that probably multiple teams work in that view, so who should be on call? You need to identify immediately who is responsible for that specific part that can jump on a call and start to fix the problem. And therefore, observability is another key part of distributed system in general, but that relies on micro-frontends or not. Okay, now that we have an idea what micro-frontends are, give or take, now let's look into how you do that in AWS. So I will show you the two main ways that I have seen micro-frontends in AWS after following hundreds of customers in the last few years. And then we will focus on the most difficult part, that is the server-side rendering part. So client-side rendering usually works in this way. You have an application shell. So when you type like mysite.com, the first thing that you are going to have is an application shell that will be there for the entire user session. And then after that, the application shell has the logic for loading one or multiple micro-frontends. It could be that you load one per time, or it could be that you have multiple per time. Bear in mind, try not to be, let's say, extreme on one side or the other one. So if you have like 10 micro-frontends that you're loading in one view, ask yourself if you are in front of components or micro-frontends. And that is a very simple. So in this case, the entry point for a micro-frontend could be JavaScript or could be HTML. Those are usually the two things that I have seen more often. And for operationalizing that in AWS, you have something as simple as an Amazon S3 bucket where you can store all your data, and then a CDN. So in our case, CloudFront. This approach here I used with several customers, and also before joining AWS, I had the pleasure to work in a platform that was live streaming with millions of customers that were jumping straight into the match for like 2 minutes before the kickoff, and that scales tremendously well. There is way less headaches for the front-end developers. The only thing that you need to do is find a way to reach an S3 bucket that usually from ACI is pretty straightforward. If you want to make, let's say, some announcement of this approach, you can also think to have some compute close to the edge. And in this case, AWS has two different types of compute. We have a CloudFront function that usually operates before you arrive to the cache layer. And then you have Lambda at the edge that operates between the CDN and your origin, and in this case is Amazon S3. So with Lambda at the edge, you can add a bit of logic. And what should be used for? A classic example that I usually have is when you are migrating towards a specific a brand new architecture. So for instance, from monolithic to micro-frontends. And what you do there is potentially use canary releases, blue-green deployment, or slicing the migration by path. So you say everything that is in /sign-in should go in the new architecture. Everything that is not /sign-in will go on the old architecture. And that will allow you to go slowly but steadily in production with your workloads and going end-to-end for a specific team. So if the team is responsible for the authentication process, we will be able to design that, deploy in production, see the behavior of the customers when they had received the new version, and potentially rolling back very quickly through the Lambda at the edge, because you can basically change how it should behave. I describe more in depth that approach in a talk that I've done as a customer of AWS in 2019. And there, basically, I explain all the complexity we were handling back in the days for migrating, for the risk in the deployment, and so on and so forth. And it was very interesting. Also, I was talking about how we optimize a single page application that was back in the days for SEO using dynamic rendering. That is a capability that you have inside many crawlers nowadays. At the beginning, it was just Google, but basically, when you retrieve at the Lambda the edge level that the request is coming from a crawler, and you can find easily from a user agent, you can redirect to an optimized version and serve an optimized version for the crawler, and you won't be penalized by the search engine. That is a great way if you are thinking, okay, I have a single page application or a micro-frontend that's doing client-side rendering, and I want to have a better positioning on search engines. But now the complexities start to raise. So that is if you want, the easy part. Scales, you don't have to think much. You just need to have these two things and have a way for moving your CI and deploying into an S3 bucket. That is pretty straightforward. Now here, server-side rendering is something that I would say is unsolved yet in the micro-frontends world. Client-side rendering, I think by now we have seen and we have good frameworks and choices in front of us, but server-side rendering is the real challenge here. And there isn't today a framework that really, let's say, get closer to the developer experience people are looking for and to the conception that are there. And trust me, there are a lot of discussion around that in the micro-frontends community. What I'm trying to do today is trying to show you the key parts of building a successful server-side rendering implementation with micro-frontends in AWS. So in this case, what you have usually in a micro-frontends that is server-side rendered is the micro-frontends. Okay, so that's easy. Those have the knowledge on where their APIs are, and they know where to fetch these data. And on the other side, you need an entry point that will allow you to either stitch everything together or do the server-side rendering. It depends if you're doing a custom implementation. Usually, this UI composer that is similar to the application shell that every time is going to be called, it knows where to find these micro-frontends, and the micro-frontends knows what to render. Instead, if you're using a server-side rendering framework, most famous one, Next, you usually do the server-side rendering part at this layer here, and then you load pages or portion or micro-frontends. Why I'm saying pages? Because if you are familiar with Next, vast majority of the time requires you to use their opinionated way to see the word, and you have your own folder with all the pages, and that basically will signal to the Vercel framework or to Next that has to, let's say, take that page and put inside a specific context with the header and footer and with all the other stuff, and then be server-side rendered. Now, you can do something like that also in AWS. I will show you an example later on Next that we are using currently with few customers with good results. But let's try to understand first what is the key challenge in micro-frontends and server-side rendering. And the key challenge today, apart from all the usual suspects like scalability, caching, and so on, is the composition part. The composition is the real challenge. And there are, if you build your own, because that was the exercise that I wanted to do, just to show you that it's not crazy complex, but there are a few things that we need to be aware. The composition part is how I can take multiple parts of my application, putting them together and serve the final micro-frontend. So there are a few options here. The first one is node loaders. Node loaders is a functionality that is available in Node for a while. It is under experimental flag. They had to rewrite node loaders a couple of times. And the challenge was because there were some memory leaks. There are some libraries that would allow you to use and leverage node loaders, like the import map implementation made by Joel, that is Dennings, that is the creator of Single SPA, and also System.js. He created like an implementation for import maps, but again, a bit leaky. The second one is ES6 remote modules. So the possibility, like you do in the browser, to call a module and load the module from a remote position, like HTTP request. In the browser is native, you can do that, no problem. But in Node is not yet. It's under experimental flag, and we don't know when will be a stable version. And also if they're going to change some, let's say, mechanisms for loading, or it will mimic exactly what the browser does. Another option is module federation. And how many of you knows module federation? Okay, none of you. Perfect. So module federation is a Webpack plugin. Is a plugin that basically takes away all the complexity of loading federated modules, so federated JavaScript. So you can have like a JavaScript file that is living inside a domain, and then you can load inside your application without any problem. That is also the way how you do client-side rendering. Is one way to do client-side rendering Micro-Frontends. You can use module federation, and you have like all your files that are and Micro-Frontends are living inside an S3 bucket. And then from the application shell, you say, I just want to load this Micro-Frontend. You pass the URL, and then module federation takes care on loading and mounting and creating the hoisting around your code, so it doesn't have any clash. There is a version also on the backend side. I would say it's more complicated that it is on the client-side rendering side, on the client-side rendering part, mainly because it's working on top of the frameworks. So, for instance, if you look how module federation has evolved following Next.js, for instance, just to take the most famous one, they had to make many changes, and still they are changing in order to optimize from taking the direction that Vercel is taking with Next.js. And now they are thinking to do that on Remix and all the other major server-side rendering frameworks. That is, let's say, it might be a challenge. I had some customers that were complaining about, let's say, being locked into module federation. So if I need to support a software for the next 10 years, I'm using this, and I don't know, and every time I am behind schedule compared to Next or compared to another framework, how can I work with that? Another option is Node VM modules. That is stable. It's an API that is available in Node for a while. And what allows you to do is taking a remote chunk of JavaScript and squeezing inside your virtual machine or VM in Node. And what allows you to do is treating that external code like it's code that you have written inside your application. Security-wise, it might be a problem, because you can imagine if you are loading some code in somehow that you need to figure out the security part of that, then you have access to exactly the same thing that you have written inside that container, Lambda function, you name it. So you have it's like code that was written there. So on security side, I was a bit nervous on that. And therefore, the last option that I've seen implemented in many frameworks nowadays, and many companies have done that, is HTML over the wire. So basically, think about a Micro-Frontend that is representing an HTML fragment. Literally, a portion of the UI that is expressed with an HTML. What it means, though, is that if we need to, because we are doing server-side rendering, if we want to leverage the hydration part, so the fact that we are appending, let's say, interaction at the JavaScript level when the portion of the HTML is rendered, you can do hydration easily like you would do with any other thing. So what you serve basically is an HTML fragment that is the rendering part with the data, and then you have a script element that is inside this HTML fragment that will allow you to load your JavaScript when it's landing on the browser. But we will see an example in a second. So how do you express this in AWS? This is by no means, let's say, the only way to do that in AWS. It's one way to do that in AWS. And now we are going through all the different parts, because there are quite few, to understand what it does. So the entry point of your application is the CloudFront. CloudFront is a CDN, but you shouldn't think of CloudFront only on the, let's say, caching part. You should think about CloudFront for many other reasons. First one is security. So CloudFront has out-of-the-box AWS Shield. That is a product that will basically mitigate DDoS attacks to your website. So also, if you have that without any caching in front of your API, thumbs up. Second thing is CloudFront, as any CDN, has multiple point of presences across the globe. That will means that if you have your API that is, I don't know, living in, let's assume, in London region, and you have a request in Australia, if you have a CloudFront in front of that, it will be picked up by a point of presence, and that request is living, and all the networking part is inside the Amazon backbone, network backbone. What does it mean is that when you do a request, latency-wise, without a CDN, it means that it has to pass through different ISPs, and you can do that. You can do a trace route on your request and see how many hops is doing. And instead, if you are putting CloudFront in front of something that even is not catchable, you have the guarantee that is going inside the Amazon backbone. So latency-wise, you can show some milliseconds. That is great. Second thing is, in server-side rendering, you need to have some static files. So as we said, server-side rendering has a technique called hydration that will allow the browser to load a specific JavaScript that usually is applied to the entire page. So it started to append all the listeners and all the capabilities. So you have like a super fast rendering because it's done on the server. The page is already filled with data. And what you do on the client side is loading a JavaScript file that, as we said before, we can use an S3 bucket for doing so. And then you need some way for doing the server-side rendering. CloudFront allows you to have multiple origins. Okay, so you don't have to just map CloudFront to a specific origin. You can have multiple of them. So you have assigned your domain to the CloudFront distribution. Off you go. You are good to go. So the second origin in this case is an elastic load balancer. That what it does is loading a Fargate cluster. And the Fargate cluster is basically a way for us to simplify and operationalize your containers. So in this case, I have a Docker container that I, let's say, define and write. I have written my code in Node.js with Fastify. And what I do is just sending the image to ECR. And then from ECR, it will be picked up by my cluster. I just defined that my cluster has 2 nodes and all the other things. But the scaling and all the other things is handled by Fargate. So for me, it's like a breeze handling that. Why I selected Fargate for this specific thing, for this specific workload? Because I envision that many customers I spoke with has the need of authenticate the request. And in order to authenticate the request, you have like some, let's say, capabilities out of the box from the application load balancer. If you're using API gateway as well, you can do authentication when the request is coming. And therefore, then you know that every traffic that is coming inside your architecture is authenticated, is a valid user that can see that. Obviously, if you don't need this thing, you want to serve your website to everyone, we will see later on how we can change this architecture. The other thing, though, that is, let's say, slightly different from any other approach, and this one is our UI composer. If you think about the diagram that I showed you before, the AWS Fargate with elastic load balancing is the UI composer. The other thing that we need, though, is calling micro-frontends. And you said that many of you are working on microservices. And what does it mean? It means that at some point you have to call point-to-point some microservice, right? Sometimes it happens. So you cannot. Sometimes you can use event-driven architecture, but sometimes you cannot because you need to have like a strict response or immediate response, and therefore you need to work synchronously. Vast majority of the time, in order to solve this problem, and also best practices embedded in many service mesh is using service discovery. And in my case, I wanted to do exactly the same, and I use parameter store. Service discovery by itself is nothing, let's say, too crazy, apart from having an API that you can send an ID and you return where you need to call that specific service. So if you say, I want to call my catalog API, I just pass the catalog ID, and then I will receive back an IP or whatever other address for retrieving this. What allows me to do that in this decoupling is the capability that I can evolve everything else, in my case, Micro-Frontends, but it could be microservices, and I just need to pass the new IP or HTTP URL for being discovered by, in this case, my UI composer. And that's exactly what we're doing. So every time that the micro-frontend that is server-side rendered, in this case, either with step function or Lambda function, is created, the first one is provision, is adding in the parameter store his own ID. So the UI composer, when says, okay, I need to load the catalog, it will check inside parameter store where to find the catalog, and then it will call a Lambda, AWS step function, an HTTP URL, an S3, I don't know, a static HTML that is living in S3, wherever you want. The beauty of this thing is that you are basically decoupling how those systems are evolving without the need to redeploy your initial part. That is what we are trying to achieve. And then you need micro-frontends, right? And micro-frontends, because our server-side render, and we said the output of those API or these micro-frontends are HTML fragments. HTML is nothing more than a specific XML, and therefore we can treat it as an XML, right? So the response of those two different micro-frontends that I created, one with step function and one with Lambda function, is HTML fragments. And that's how it works. Obviously, you can create how many you want. You can use also other approaches. We will see in a second how it works. Okay. So next one. Okay, perfect. So let's try to mimic what happens. So when a request comes in, the first thing we do is go inside the Fargate layer, right? So I'm using Fastify. We have product details coming in. When this happens, we have a specific thing that we need to take into account. Is this transform template that receives the catalog template that is basically like you would do in server-side rendering. You have like an HTML template that could be wherever. In my case, I created nothing that is too crazy, but I try to be as framework agnostic as possible, because I don't want that you think, oh, I can use only, I don't know, ETA, or I can use only handlebars or whatever it is. You can use whatever you want. So this one is inside an HTML page. I just set all the static files. So one challenge that you have in micro-frontends with this approach is I need to share my dependencies. So every micro-frontend should externalize the dependency, and then you have the external, so the common dependencies that are here. In this case, I use Preact, HTM, and non-events as my external dependency are loaded once every time that you load the page, and off you go. You have solved that problem of the dependency. Second thing is, as you can see here, I created these custom tags, micro-frontend, that has an ID, error behavior, and the loader. That basically signals how I want to, which is the ID, where to find the micro-frontend, in this case, the ID, how it should behave in case a micro-frontend is returning an error, because it could happen, and you need to figure out how to handle that, and which is the loader that you need to use. Then you can also say the loader could be moved in another place. I could agree or disagree, but for now, it is in this way for this example. Now, a loader is something like that, is literally leveraging the AWS SDK for calling a step function, a Lambda function, whatever. As you have seen, I'm not using any HTTP API gateway or any API gateway. I go straight to the service, because what is my security mechanism? IAM. Because IAM allows us to really go granular on the way how we are handling that. It's a service that scales dramatically and is fully managed by AWS. So I don't have to do anything. I just need to set it up. And this one, I created loaders for step function, Lambda, S3, whatever. And then what I do is, this is the logic that I created. I try to comment. I hope that is big enough. You can see that. So in the first part, what I do is when I retrieve the template that I created, here, as you can see, I'm going through the template. Again, it's just XML, so I can parse it. And I'm going to retrieve all the elements that have a micro-frontend tag. And that basically will retrieve the ID, error behavior, and loader, the three things that I need that. That basically, if you have like 10 micro-frontends, it will be stored inside an array, and you have, let's say, what you need to handle. After that, I retrieve which are the services that I need to call. As I said, I have the ID of the micro-frontend. So I go to parameter store and said, I need the catalog and I need the reviews. And that will basically return the ARN, that is a unique identifier for calling either step function or Lambda in this case. I then call through a promise all my micro-frontends, and then I analyze the response. Why that? Because it could happen that, like in microservices, for any given reason, I don't receive a response. I receive a 500, or the response takes, I don't know, 30 seconds, and we cannot wait 30 seconds for return something to the customer. Therefore, you can. I set this idea of error behaviors that allows you to say, I want to trigger an error because that is a micro-frontend is fundamental for the experience of the user, or I want to just let's say provide stale data or a placeholder, whatever. And then finally, I take the HTML fragments and put inside the template, and that is basically what I return to the customer. As I said, IAM is my friend. So what I said is this Fargate cluster, what it can do is just invoking a function and start a synchronous execution of a step function in a specific region, that is where I deployed, and in a specific account. So I just nail down the potential of breaches that could happen at the Fargate cluster level. Now we move into the Lambda function. So let's see how a micro-frontend works. First thing, as I said, that every time that I deploy my micro-frontend, I do is calling parameter store, storing which is the ARN, unique identifier for my review micro-frontend in this case. So I know upfront that when I call the review element into my parameter store, we return the ARN that is my, if you want, a URL to call my Lambda function. And here, as you can see, it's nothing too crazy. It's literally same code that you would write inside an application server. I'm using Preact and HTML. Why I'm using Preact and not React? For one reason, Preact is 3 kilobytes. It works fantastically and has a built-in feature that I really love, that is partial iteration. Partial iteration is a it's a possibility that you have with server-side rendering that basically, instead of like you would do usually when you do in a monolithic application, you load the entire view and then you hydrate the entire JavaScript code. It might be that the user never scrolled down. So why you need to hydrate that? So we came up with the idea of a partial iteration as a community. And partial iteration basically allows you to say wherever is in the viewport, it will be loaded. Whatever is not in the viewport, it won't be loaded. And that basically allows you to enhance your performance, obviously. So in this case, what I do is just rendering this component called review. And here you see the partial iteration. So I add the review.js, that is basically the logic I want to run into that I want to run in the browser, that is loaded when this is deferred. I can do even more. You have a native API in the browser that is called Observer. Okay, I forgot the name. Basically, is an observer, so it's a stream that allows you to, when you scroll the page, the UI is when the user scroll the page, basically you will trigger from this stream that the page was scrolled, and then you can start to iterate this stuff. And there are frameworks that are doing that out of the box, okay? A classic example you can find, there are articles around that, is the Etsy web store. The Etsy web store is using Preact, and Preact has this out of the box without any problem. Okay, cool. So now I wanted to give a twist and say, okay, everyone was thinking, oh yeah, well, I create a micro-frontend, I use Lambda function, I use a container, whatever. But what about step function? Step function has a capability that is called synchronous invocation that allows you to call synchronously, okay, like it would be with any other system, right? So I can create a micro-frontend from it. And the beauty of this approach is that it's really low code, because what I'm doing here is I'm using two Dynamo tables because what I want to do is creating a cache of my micro-frontend. There are micro-frontend that don't have to be computed every single time. You can store in a cache and serve from the cache for having a super fast response. So if, for instance, in this case, I cache my micro-frontend and the output of my micro-frontend and store inside this checkDB stage where I have a DynamoDB table that I check if there is something computed, then my response time of this micro-frontend, I don't have any HTTP, just to remember, is 10 milliseconds, 20 milliseconds, something ridiculous low. And if, in worst case scenario, I don't have anything cached, I have to go through this branch of my state machine that I retrieve the product data from a DynamoDB. I call a Lambda function for doing the rendering, and then I cache the micro-frontend. So this is splitted, and potentially I could have just one thing, because with step function, you have the possibility to call directly any AWS API from the step function code, or better, the configuration. That means you don't have to spin up any compute. You just go straight to a DynamoDB. I want to call the get item API, retrieve which is the ID that is passed at the beginning inside the step function request, and basically you avoid to spin up any container, any business logic, wherever. You just retrieve the data and pass to the next stage. That will be the product rendering part that will handle the server-side rendering part and the output in HTML. So this is the code that you have to maintain. You have a request that is coming there. You see that at the top, asynchronous event. You unmarshal the data because it's coming from DynamoDB. So you just have basically a JSON. And then you treat like a JSON. You do render. This is the HTML that I want to render. Book title, book author, title, done. This is the code that you need to run. This is the only code that is inside my Lambda function. Nothing else. Obviously, this is an optimistic view of the world. You need to handle also the potential errors or data that are not well formatted or whatever it is. But as you can see here, there is no business logic, because my business logic is the state machine, right? So I have now a micro-frontend that is low code. I need to maintain, and we know that code is liability. We said also before, and I just need to maintain this part here. And off you go. You have like a server-side rendering micro-frontend with almost no code that you need to maintain, and you have the performances that I described before. Also in this case, same thing. When it's provision, I just append the ID into this parameter store that will allow me the discoverability. If I don't do that, the drawback what would be that I need to redeploy every time the Fargate cluster. That I don't want to, because I want that my teams are independent, right? So I want that they can work independently on that part. So there is one thing that I didn't mention. This is the example that you can find. I will share at the end the repository with the whole code and all the other things. But here the example that you have. So this is a micro-frontend, the green one, and then you have like the yellow one at the bottom. So those are the two micro-frontends we are rendering. But there is a third one that is hidden: notification system, big classic. Notification system cannot be server-side render because it has to react on what happens in the UI. So this one is a micro-frontend that is completely client-side rendered. So I can show you that you have like, you can mix and match wherever you need based on your project, different tactics and different way to do things. So in this case, if I click buy now, you have this notification and bubbles in and then disappear. Now, the problem you have with micro-frontends is I have multiple micro-frontends in the same view and I need to communicate together. Vast majority of the people that start this journey try to solve this problem with exactly the same way with the monolithic architecture. So they create a global store, Redux or whatever other state management you're using, and they just rely on that. The problem with this is that you are creating design time coupling. So if now I have to change for any given reason a parameter inside my store, or I need to add, remove, I need to retest everything that is inside that page. What you could do for solving this problem is using events, like in event-driven architecture. We have several talks about that. So how can you do that? It's as simple as having an emitter, for instance, or custom events, depends what you want to use, available to your front end, and then basically say, when you add the to cart, so I click buy now, I emit an event, it's called add to cart event, with a bunch of information, but you can also emit not having any payload. And on the notification side, you just have the add to cart event. off you go. You have like two systems that are completely decoupled. They communicate through events, completely testable, because I don't have a third system that is a global state manager that is shared across elements that it can be out of sync. You have to maintain, I have to coordinate with multiple teams. I don't have all of that. I just have an event in, an event out. That is super simple to handle. And also, if no one is listening to that event, surprise, surprise, the code doesn't break. You don't have, let's say, errors in the page. You don't have anything. It's literally super safe. There are a bunch of considerations that we need to think about, so I can then wrap up. We recently announced the possibility to have streaming capabilities on AWS Lambda. And that means the Fargate cluster I was using also probably mainly for the fact that I want to have authentication and I want the possibility to have stream and potentially even an order stream to handle, now can be handled with AWS Lambda. A specific one, what is called function URL. Basically, we will take care of creating an endpoint for you. On that case, you don't pay a dime for that, so it's completely free. It's just you pay for the Lambda function invocation and execution. And the beauty of that is because it's a public endpoint, you can obviously have as origin of your CloudFront, and therefore you are removing the load balancer and everything else. In favor of the Lambda. Now, how it looks like? It looks like that. As you can see, we changed the entry point, so it's not just an asynchronous function. You have AWS Lambda Streamify response. That basically is signaling that you have you are streaming the content. And there are some limitations at the moment. It works only with function URL and between the communication between Lambdas. So if you call a Lambda from another Lambda, you can use streaming. At the moment, it's like that. And you can see more about the launch that was literally last week at this URL here. So if you're interested, there you can find more. As I mentioned next, so this is a different approach of an architecture that you can build with Micro-Frontends and Next that are designed for a bunch of customers. And the idea here is this one. So if you split your Next application through pages, what you need to do, and that is applicable with any server-side rendering framework, what you need to do is every team is responsible for a page. I need to have these tiny fragments that will allow you to be loaded using module federation inside the application shell. So where do I store my fragments? Because at the end, module federation, what it does is literally exporting a bunch of JavaScript files. It handles already the dependency and everything for you is literally the output is a bunch of JavaScript files. So you could store in S3 and off you go. The thing is, if I want performances and performance matters in server-side rendering, I need to have something that is extremely fast to load. In this case, we have the capability to use Elastic File System. That is a feature that is available for Lambda function for a while. And all the Lambda functions that are spin up simultaneously can fetch the chunks directly from there. It's extremely cheap because you don't have, let's say, large website that counts gigabyte of JavaScript files. Usually, probably you will be, if you are in a bad situation, 10 meg. You can also handle, let's say, the possibility to let's say, discard old files. You can also thinking to store these chunks into the Lambda function till the execution environment is up and running. And then when a new one, it will only fetch on EFS when there is a new one. But this one provides fantastic performances compared to going through S3. The reason being is that it's basically having let's say, a network file system plugged into a Lambda function. Therefore, the only thing that you do is your automation pipeline could store stuff in S3, and then you have like an event that is triggered that basically is storing the file into EFS, and this is your application that is using Micro-Frontends. As simple as that. Once again, we have a lot of primitives available in AWS, and that allows us to create these kind of things. Otherwise, if you have everything managed, you might risk to not have the full control of what you're doing. Obviously, there are a gazillion of other things that we should talk about, like caching, consistent user interface, discoverability, and so on and so forth. And the talk, unfortunately, is only 45 minutes long, so I cannot cover all of that, but those are definitely, including governance, key things that you need to think when you are building micro-frontends. If you're interested about the example and going more in deep, I started a series of blog posts in our Compute blog, and you can find the link here. Currently, I published last month or 2 months ago the second article. I'm writing the third one that I'm starting to go more in deep about the UI composer and the possibilities that are available there. And basically, it's an extended version of what I'm talking, what I talked today on this conference. Main takeaway of what we have seen. So first of all, if you have distributed architectures, you could apply them also on the front end. Micro-frontend are not only a technical, let's say, a technical capability, but is also an organizational one. Allows you to create independent teams that can collaborate together, but they are not constantly coordinate. And last but not least, serverless can be leveraged to do end-to-end distributed architecture from the front end to the back end without any problem, as you have seen. And the performance is great. You just need to enter and shift your mindset towards the serverless world, but is something that is totally doable. That's all I got. I hope that you enjoyed the session. And if you have any question, I will be around for the whole day. I don't want to, let's say, delay your lunch. So if you want to ask question here, I'm here. Just hit me. But otherwise, feel free to ping me anytime. Again, I hope that you enjoy and enjoy the rest of the conference.